Today we are going to tackle Element 1 under core mathematics, and the aspect we want to tackle is about polygons. So at the end we should be able to find examples of polygons. Then we are going to end it on how to find the sum of the interior angles of a regular polygon. So some of the polygons are triangles. So you have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. It goes on and on. So these are some of the names of the polygons. They want to see the number of sides these polygons have. So let's write it here, number of sides. Triangle, we know, have 3 sides. So this is a shape of a triangle. You see it's having 1, 2, 3 sides. Then a quadrilateral. The quadrilateral is a 4-sided figure. So this shape is a quadrilateral. So 1, 2, 3, 4. It's having 4 sides. Pentagon. It's having 5 sides. So 1, 2, 3, 4, and 5. So 5-side figure is called a pentagon. So what do you think? Hexagon will be a 6-sided figure. Heptagon 7-sided. Octagon 8. Nonagon and 9. So we want to see the number of triangles you can get out of each of these polygons. So we want to see the number of triangles. For the triangle, I can see 1 triangle. So let me come to the quadrilateral, which is that 4-sided figure. How many triangles I can get? For us to get a triangle, we choose one place as our starting point. Then we do form the triangle out of it. So I can pick here. So how many triangles am I seeing? I can see 1 here, 1 there, making it 2 triangles. Now, this is our 5-sided figure called the pentagon. I want to see the number of triangles I can get. So from here, I form 1 triangle. From the other side, I get 1, 2, 3. I get 3 triangles. So let's look at a 6-sided. 1, 2, 3, 4, 5, 6. I want to form triangles. I get 1 triangle. Another. So I get 1, 2, 3, 4. I get 4 triangles. So automatically you know that the heptagon will give us what? 5 triangles. 6 triangles, and on and on. Okay. I want to see the sum of the interior angles. The sum of the interior angles. Meaning I'm supposed to know the angles inside, and when I add, what will I get? So I pick the first triangle, I see this angle is inside. And we said the sum of the interior angle of a triangle add up to 180. So I get my 180 for the triangle. Then from here, the quadrilateral, I saw this angle that and it's giving me 180. And I saw another one here give me 180. So in all, I get 360. So let me come to this one. I see 1, 2, 3. Then I saw another 1, 2, 3. 1, 2, 3. So this one is 180, 180, 360 plus another 180, making 540. 540. I can continue for the others also. I can also write this that I saw one triangle and each triangle said the interior angle add up to 180. This one I saw 2 triangles. And if I multiply each by the sum of the interior angle of 1, I can get the 360. So this one also will be 3 by 180. So I can say that there is a relationship. If I compare the number of triangles here, I could say that the number repeating is every day. 1, 2, 3. So if I don't know the total for the hexagon, but per what I have done, I can say it is going to be 4 by 180. 4 by 180. How did I know? Because I said the number of sides, the number of triangles will be multiplied by 180. So if I multiply 180 by that, then it's 720. So from here, I can say that the number of triangles in the heptagon is 5. Therefore, the sum of the interior angle of a heptagon will be 5 times 180. How did I get to? I saw it from here that I always get the number of triangles, then I use it to multiply 180. I saw I had 2 triangles here, I multiply by 180. 3 triangles here, I multiply by 180. 4 there, I multiply by 180. So if it is 5 sides, then I'm going to multiply also by 180. So if this side, the next one was 6 by 180. Okay. Then, how did I get the 6? If I don't want to draw, how will I get the 6? I compare the number of sides to the number of triangles. So let's assume I have a polygon by name having n side. How many triangles am I going to get out of it? Let's check from here. It was 3. Change to 1. The number of triangles was 1. It was 4. Went to 2. 5. 3. 7. 5. 8. 6. So what do you think is happening? Whatever I say is happening here, the same thing should run through. So 3, what will you leave to 3 to get 1? We agree I have to subtract 2. So let's check whether it's correct. 4 minus 2, 2. 5 minus 2, okay. So if the number of sides is n, then how many number of triangles am I going to get? It's going to be n minus 2. Because let's check. So let's assume the sides are 50. Let's go to 50 minus 2, giving us the 48. Because here was 6, so 6 minus 2 gives us 8 minus 2 gives us the 6 rather. The 7 minus 2 gives us the 5. So if I get the number of sides and I subtract 2 out of it, that one will give me the number of triangles. And we want to come out with the sum of the interior angles of a regular polygon. We saw that always the number of triangles will be multiplied by 180. So from here, I can say this is going to be what? N minus 2 multiplied by 180. Therefore, I can say that the sum of the interior angles of a regular polygon will be the number of sides minus 2 multiplied by 180. So I can see that n stands for the number of sum of the interior angles will go to be n minus 2 by 180. So here the variables are just 2. The number of sides, which is being represented by n, and the sum of the interior angles, which is being represented by S. So the questions are just going to be in two ways. Either they ask you to find the sum, then they are supposed to give you the number of sides, or they will give you the number of sides for you to find the sum of the interior angles. Okay, so let's assume, what do you think it will be? If I have a regular polygon and the number of sides is k, what do you think the number of sides will be? Correct, it will be k minus 2. What will be the sum of the interior angle? It will be k minus 2 multiplying 180.